Afternoon. Welcome to our first session of Onward Essays. I'm honored to be able to chair it today, particularly since this is my first session of Onward Essays as well. We have two talks this afternoon. Our first is from Advait Sarkar from Microsoft Research. And he's talking on a subject that I'm very interested in, as I've been an advocate of text-based programming modalities for end users for quite a while. And of course, the advent of large language models makes us wonder whether or not we're going to continue to do that. So today, his talk will be on whether or not code will remain a relevant user interface for end user programming with generative AI.
Thanks everyone for coming to the last session of the day, and hope you've rejuvenated a little bit with some Pastel de Nata. Actually, I didn't spot any. Maybe there weren't. Maybe there was some simulacra of Pastel de Nata. My name is Advait Sarkar. I'm a researcher at Cambridge, at Microsoft Research Cambridge, and a lecturer at the University of Cambridge and UCL. My background is quite this is my first ever splash, so I'm quite excited to be here. There's new community, new audience. My background is in human-computer interaction research primarily, so most often you'll find me at CHI or the end-user programming conferences like VLHCC, but I'm excited to be here at Splash with many of my colleagues have roundly endorsed for multiple years. So I'm curious to see what all the fuss is about. There are some links down there. If you want to yell at me on the internet or just say hello, please go ahead and find me. So let's get started with my talk, which is about will code remain a relevant user interface for end user programming with generative AI models? And this is quite a long title because I'm kind of bracketing a lot of words so that I'm just to be a bit more precise about my claim. But if we're going to be a bit loose about it, get the essence of it, what am I asking? I'm asking, is code going to still matter for end user programmers in a world with generative AI, right? So what is end user programming? If you've not come across this concept of end user programming before, it's similar to the idea of citizens that we heard earlier today. An end user programmer, quite simply, is somebody who writes programs for their own use. They're not professional developers. So somebody's writing a spreadsheet formula for their own use, somebody who is writing a bit of a script to help them with an office task, somebody who's doing budgeting, data analysis at home, a scientist who is working on some sort of code to analyze their experimental data. These are all people who are not producing software for consumption by others. They are consuming the code themselves, so they're end user programmers. Now, one nuance that's not always the case for end user programmers, but it's typically the case, is that they typically don't have programming expertise. So they've typically not taken any courses in programming. They've not obviously typically got a background in computer science. Whatever they know about programming, they've maybe cobbled together expertise by trial and error, by learning from colleagues, by going on some short courses maybe that they're offered on the job. So they're not trained to think like computer science, they're not trained in programming. And this causes a lot of challenges because then they try to program, they try to use the apparatus of professional programmers to get their jobs done. And so end user programming research, by and large, aims to bridge these gaps in expertise. And so the aim of end user programming research, by and large, can be described as we want to improve the ability of non-experts, end-user programmers to use formal systems. And by formal systems, basically I mean code. There are other elements of the system that might be also formal, but they might be graphical and visual. So for instance, in the spreadsheet, the grid is an essential part of the language, but it's not necessarily, you wouldn't describe the grid as code. But effectively, you can just replace formal systems with code and you'll get what I mean. And there's three approaches to help bridging the gap. One is to help users learn. So this is where there's an overlap between computer science education research, so developing new tutorials and so on. Another way is to help reduce the expertise requirements. So you have a visual language like Scratch. Scratch has features that help people avoid type errors, so you can't have a block of a certain shape going into a hole of a different shape. and finally, you can try and reduce the programming requirements. And what I mean by this is reduce the need for people to actually write literal code statements. So things like programming by example, programming by demonstration, don't necessarily eliminate programming requirements, but they aim to reduce how much code you need to write, how often you need to write it, and so on. So this is the status quo for end-user programming research. This is what most of the papers at a conference like VLHCC will be about, for instance, right? Now, what does generative AI do to this picture, right? And by generative AI, it's a very sort of muddy term. In this paper, I'm just talking about end-user tools, stuff that people actually use, not something abstract like the transformer algorithm or whatever, and applied to programming, so not ChatGPT for text generation, but talking about it in the programming context, based on generative deep learning, so sort of current generation of AI technologies. And this is interesting because because there's, unless you've sort of been really focused on something that's not generative AI, you'd be aware of a significant leap in capabilities, as measured by benchmarks as well as by practical use in a number of categories of programming. So authoring code that does some task based on a natural language prompt, debugging some code that has an error in it, reusing code and reappropriating some code in a different code base. All of these kinds of tasks are tasks that with generative AI has seen a significant leap in sort of benchmark capabilities in the last couple of years, right? And so what is this going to do, or what might this do to end user programmers? So I'm going to posit this hypothesis that we'll see a sort of a shift, a leap, which would be a radical widening in the scope and capability of end user programming due to generative AI. And you can think of it as 3 dimensions. So end user programming will be applied more deeply to existing tasks. So people are currently maybe writing formulas and spreadsheets to do certain simple things like sums and averages and so on. And maybe we'll be seeing formulas to do much more sophisticated things in the future. I mean, some people write those very complicated formulas, but more people might. There's an extensification, so people might apply end-user programming in more tasks that they weren't applying it before. So, for instance, automating things across multiple applications. And then acceleration. So people will apply end-user programming more frequently across all their tasks. And this is especially going to be the case. It's especially going to be the case that that the cost of applying end-user programming is going to go down because it costs very little to just try to automate something in comparison to what it's been. So I'm not going to. So what evidence do I have that any of this is going to happen? I don't have any evidence, right? This is speculation based on sort of nascent trends. The rest of my talk is going to try and analyze, well, okay, in a world where people are doing a lot of end-user programming and primarily doing it using generative AI, what remains the role for formal systems, for end-user programmers, right? What could be still the value proposition for engaging with code, writing it, reading it, and so on directly, as opposed to through a large language model, for instance, right? So I just talked about this slightly. Will code remain a relevant user interface for end-user programming if people can code with natural language, right? So here are some reasons why code might still matter. And I will say that I'm not the only person to have asked or tried to answer this question. There's like many viewpoints here. This is my perspective, which comes from the research that I've been doing with my team over the last 10 years, studying particularly end users doing data analysis tasks in spreadsheets. So that's the kind of small world in which I'm located and how the world looks from where we're standing. Okay, so AI makes mistakes, right? It can't automate everything, And if AI makes mistakes, what better way to understand and rectify those mistakes than to learn how to code, right? So this is a good reason that code might still matter, or learning to code and engage with code might still matter for end user programmers. However, we might say that this is a problem that sort of steadily diminishes over time. As generative AI improves, it might be able to do things much more accurately than it can today. Indeed, that has been the trend. But a counter-argument to that is, as AI improves, the demand for what we want to make it do also improves, right? So there's a kind of, this is known in economics as as Jevons paradox, or a rebound effect, where basically, for instance, if you think there's a traffic, if there's a road that's like jammed with traffic, and you think widening the road is going to help with the traffic jam, you widen the road, and all that does is increase demand for traveling between the two places, and so you end up with, you know, the same kind of latency or whatever on the road as you started off with, and so the same thing is likely to happen. Indeed, we see this with many end-user programming scenarios. As soon as a capability improves, the demand for what you want to try to do with it also improves along with it. So this issue of limited abilities may not ever go away, even if generative AI continues improving. Right. Yes. So the second reason is that code offers really fine-grained and direct steering of things. So for instance, if you don't want to use a particular API because it's very slow or it's deprecated or it's insecure, if you're writing code, you just don't use that API. But if you're writing code via a large language model, you have to try and prompt the large language model not to use the API. It may not honor your prompt, and so on, right? So there is a sort of indirectness to coding that we don't. Sorry, to using LLMs that you don't have when you're using code directly. But you can give control to end users, or increased levels of control without also interacting with directly with code. So interacting using faceted natural language, for instance, which is mentioned in the paper, is one alternative. And I don't think this is a solved problem. I think this is an important area for future research. A third reason code might still matter is agency. So agency is related to control. Agency is like the perception that you are having an effect on things. It's a sort of psychological construct. It's the feeling of being in control, of being able to effect change. And numerous studies have shown that when people have a perception of agency, they have an overall better experience using a computer and carrying out their tasks, right? And also, coding gives people agency, so also borne out in studies. But the other thing is that agency is multi-level, and it can be easily manipulated. So for instance, like a notorious example are these placebo traffic light buttons, where when you cross the street, you press the button to change the light, and in many cases these buttons don't actually do anything. The light is just on a timer, but it's there to give people the feeling that they're in control of something. So you can manipulate agency, and it's also multi-level, right? So if a user can write code that they couldn't without an LLM, if they find that over the long term they can actually get a lot of their tasks done, that might give them a sense of overall agency, even if in one particular task they feel like they don't have fine-grained control over the output of what's happening. So it's a multi-level phenomenon. Okay. So another reason is that is called awareness of the possible. So learning to code gives you a language with which to think about what can be automated, how to achieve something, right? So for end user programmers, think about somebody who's trying to automate an office workflow. It must even occur to them in the first place that this workflow can be something that is automated, right? And this is something that you often, informally you might have this experience of seeing people do something manually that you know can be automated, but they don't know it can be automated. The reason you know it can be automated is that you have this language of thought about the possibility of what can be done. And coding gives people that possibility. It's no use having a large language model that can write code for you if you don't even realize that you can solve your problem with code in the first place, right? Again, you can try and get this without code. So there's research into sort of proactive systems, early systems on programming by demonstration, and mixed initiative systems try to help people identify opportunities. So this is also something you can get without code, and I think also another area of research. So I'm not necessarily sure that this is, for instance, each of these is like an unassailable bastion that will mean that code is always going to be important for end user programmers, right? Similarly, explanation, interpretation, and debugging code can be useful. So for instance, take something as simple as an off by one error. It might be really difficult to diagnose that you have an off by one error unless you literally look at the code. So code can be useful, and formal systems offer a very predictable route towards debugging and fixing errors. The problem is that it's already really challenging for end user programmers to debug code. Right, there's so much research on making program visualizations, making debugging aids, and as code becomes more complex, as the generated code becomes more complex, this problem that debugging is a challenge will get even worse. So I'm not sure that relying on code to be a direct interaction with code as a debugging support is necessarily a long-term sort of effective strategy. Another reason is that code might still be useful is trust. So when somebody writes equals sum in a formula in a spreadsheet, they trust that the output that they're getting is a sum because they trust the named entity of sum has been implemented correctly by a responsible third party or by a responsible party, in this case Microsoft, right? And so being able to directly kind of correlate names and identifiers with verifiable procedures has its own value. There's a strong value proposition there. And I'm not sure this can be entirely supplanted with large language models, because you can ask large language models to explain code in naturalistic language, but there's always this error of hallucinations. This possibility of hallucinations. I think it may be possible to constrain explanations to refer to trusted and verifiable procedures. And this is, I think, an interesting research area that would require collaboration from programming languages researchers, design researchers, and end user programming research to sort of tease out, machine learning research to kind of tease out how do we constrain a large language model's explanations to provably refer to verifiable procedures. Sorry. So this final meta-level observation is that, in this view, which we've noticed in our studies of people who use Copilot and similar tools, is that in this view, code isn't going away. It just looks different. It's the prompting language that it takes the place of code in this new world, right? Because prompting is hard to learn. It's kind of quite specific sort of tricks and craft practices required to coax an LLM to do what you want it to do. So there's actually quite a lot of expertise and sort of formality there as well. But this characterization that it's just one level of abstraction higher than code, it isn't satisfactory to my mind. It's not a satisfactory characterization of what is going on here. Because I think you can't actually deny that there's a huge increase in the flexibility of the expressions in prompting language in comparison to a formal system like a programming language. And it's not clear whether, as generative models get better, and what I mean by get better is made clearer in the paper, whether this prompt engineering will remain a form of skilled craft practice that is distinct from ordinary communication skills, or whether we'll have generative models that reach a point where they can interpret sort of truly natural language at human proficiency. But a counterpoint to this is that the whole imprecision of natural language, particularly when it comes to mathematics, philosophy, logic, and science, the imprecision of natural language has long been seen as a drawback of natural language, right? Since sort of probably the 1500s, people have been trying to make sort of perfect natural languages, artificial languages in which you can only speak logically correct truths and so on, right? And the program of the most sort of recent iteration, the 20th century program of analytic philosophy, which was born out of such concerns, eventually gave rise to our modern programming languages. So it is interesting to see that generative AI is bringing us back full circle to natural language. So what I think is more likely is that rather than prompt engineering remaining like programming, but at a high level of abstraction, we'll see the application of language formality for, say, precision or brevity in future systems. We'll see it become a bit more social and discretionary. So what I mean by that is that language for instructing generative models may develop much like a scientific or like a legal language has developed, right? So if you think about, these languages are ways for scientists and lawyers to develop, to communicate more effectively. They're extremely structured, although they have quite a lot of flexibility also. They have a lot of specialist terminology in them. But these languages have developed kind of organically and through sort of power relations that are enacted by individuals and groups and institutions. And I think a similar way of development of prompting languages is going to be what happens. So what are the implications for end user programming research, right? I have sort of a set of implications in the paper, but I'm only going to talk about 4 or 5 in detail. So the first is this issue of learning to fish that people ask in the end user programming community. So if you've not come across this before, there's a parable of the man who is being taught to fish or being given a fish, right? And the parable goes, give a man a fish and you feed him for a day, teach a man to fish and you feed him for a lifetime. So the moral of the story, the implication is that learning how to make somebody self-sufficient is better, because then they can always kind of satisfy their own needs. And the question with generative AI is, does it still matter? Oh, sorry, that is too early. Does it still matter for this man if he can get a fish whenever he wants, basically, right? Does it matter that he doesn't know how to fish for himself if whenever he asks for a fish, he gets one, right? That's the kind of position that we might be in. And while code still has these benefits, I think we might have a more nuanced analysis of what actually are the trade-offs for people to learn coding in the end-user programming scenarios. And I think a really good, because for end-user programmers, the task comes first. They're not trying to write code because they're interested in making a beautiful reusable program. They're just trying to do their budget or whatever, automate their workflow. So the task always comes first. They're not interested in programming or learning how to program, except for some categories of end-user programs. But this is generally the case, right? And I think one of the really interesting papers of recent years has been written by Pothast and others, called The Dilemma of the Direct Answer. And they talk about this tendency in search engines. Rather than giving people a list of result pages, they try to answer the question directly, just by providing a paragraph of answer of what the question you asked is. And so Pothast do a really nice analysis of the trade-offs, both on the human side as well as the system side. Like, what are the benefits of being able to read multiple pages and come up with your own answer, even though that takes more time and so on. And I think a similar kind of trade-off is at play for end-user programmers here. The second implication, I don't know how much of a concern this is in this community, but it's a big concern in the research communities that I told you about earlier. There's this pattern of publications which has been called Bertology, where people basically try to publish a paper where the whole point of it is, can a large language model do X? We made a benchmark to see whether a large language model can do this task. And we found that yes, it can, or no, it can't, right? So this kind of Bertology is a really common pattern of paper publication, and I don't think it's very helpful, because firstly it puts researchers in a passive stance. It sort of makes us not the people who are actually building these things. We're kind of probing it from the outside like a black box, and so it's kind of exciting to even know whether this black box can do something or not, right? So this is a little bit ranty, and you might disagree with me on this, but I don't think this is very productive. And the other reason it's not very productive is that it's very quickly sort of outdated as well, right? This is not an enduring contribution that can a large language model do something, yes or no? Well, maybe 6 months down the line, the answer is yes, or maybe still no. I don't know. It's hard to justify that as an enduring contribution. What I do think we need is standards of rigor for prompt development. So people are already starting to say, so I think large language models are powerful, and we should be using them in our research, but we should be trying to answer more interesting research questions. And what we need is sort of more reproducibility. So people are already starting to publish in appendices what their prompts are and so on. But I think what we also need is more rigor for what it means to develop a prompt for a large language model, right? How many times do you try something? Is it trial and error? What kinds of patterns of language are you exploring? How many people are involved, and so on. And we have standards of rigor like this in other parts of qualitative research practices. So I think we need that here as well. So this one, end-user software customization, again, I'm taking this idea of substrate from Tomáš Petříček, and the idea of a programming substrate is easily illustrated in Microsoft Excel. So a substrate is a programming environment that allows you to make some changes to your software. So Excel has 3 at least substrates: the formula language, which is relatively easy to learn, but you can't actually change a lot. You can't do a lot within the formula language. You can do calculations within the grid. Contrast that to, say, VBA, right? With VBA, it's a little bit harder to learn, but the scope of change is greater. You can do more stuff. You can change more stuff in the interface with VBA. And then finally, a third substrate might be the C++ code base of desktop Excel itself, right? It's much harder to get into. It's much harder to make modifications in terms of the expertise required, but in terms of the scope of what you can change in Excel, it's pretty much arbitrary, right? So these are the different programming substrates. The ability of generative models to target different languages might mean that we find some sort of universal substrate. So Petříček is this hypothetical universal substrate that we can make any change, but it's also really easy to learn if you just want to make a small change, right? So I think this might be a potential application for generative AI, where you use the tool to achieve a task, but the tool sort of federates the task out to the appropriate substrate. So if you need to do something that can be solved using the formula language, it generates a formula. If you need something that requires VBA to solve, it generates VBA, and so on, right? But this makes a really interesting question about what is the status of the application. So the sort of theory of application in human-computer interaction, like why are apps what they are? Who's decided what a feature set of an application is, right? It's a negotiation between developers and communities. Maybe there's like some nucleus of activity or some file type or something that starts like, this is the kernel of what this application should be about, and then we add features as time goes on and as the community develops and as needs develop and so on, right? But if you can arbitrarily script your application, what does that mean? How do applications relate to each other when you can write scripts that automate workflows across applications? Do we still need that same relationship with developers who are trying to pack something with features if quite a lot of bespoke functionality can be generated on the fly by the end user? So this field of end user customization, software customization, which is a subfield of end user programming, I think is really going to be transformed. Because what applications might look like will be quite different depending on how much of the feature set can be kind of dynamically generated on the fly. Right. Okay, I'll skip over the cognitive dimensions point. The final point I want to make is this question of attention investment. So Blackwell's attention investment model is a sort of core part of end-user programming theory, and it explains the behavior of programmers in deciding whether to automate something, i.e. to write a script, or to try to do whatever they were going to do manually, right, by hand. So it's a cost-benefit analysis. People are likely to pursue automation if they think that that they're going to save time and they're going to succeed at writing that program to do whatever it is, right? But what happens to this model when the programming costs kind of tend to zero? So it doesn't cost anything to ask a large language model, or very little to ask a large language model to try and write a program to do something, right? So when these costs tend to zero, there might be other costs that dominate the automation decision, rather than simply people's perceived cost of how much time is going to take me to write this code, and whether whether I'm going to do it correctly or not. So other things might dominate this. Some things like whether people feel that they have the agency to write this LLM prompt, or whether people trust that the LLM will do the right thing in a particular scenario, right? Or maybe there will still be a cost-benefit trade-off in terms of attention, but these attention will be spent on new categories of activities that don't currently exist. So these are some other implications that I won't be able to talk about, but they are in the paper if you're interested. So just to conclude, so this generative shift moves the focus of end-user programming from helping people use formal systems and learn formal systems to new issues around control and explanation and agency. And I do think that this if something like this happens, it will affect many core theories and concepts of end-user programming, such as end-user software customization and attention investment. So I think it's worth anticipating some of these changes and trying to get ahead of the curve in terms of planning our research agendas for like what kinds of design interventions might help the end-user programmers of the future who are not necessarily engaging with code to the extent that they do today. All right, thank you very much.
Thank you for your talk. So one of the questions I had, some of the work that I've done has been in talking about, when you were starting, you talked about some of the needs that we may still have for code, why it's good. And so one of the things I've worked on is the code as a mechanism for explaining a procedure, how you do something, not only to the user themselves, but to others, to share knowledge, problem-solving knowledge. Can you give some thoughts about when we move into a prompting model and we start using generative AI, how that may evolve in this model?
Yeah, I mean, so using code as a way to communicate with others, right? Communicate your ideas, communicate your intent. Again, that I think the aspect that perhaps touches upon that question most is the idea of how prompting languages will evolve in the future, right? So we've done multiple studies of multiple different kinds of systems that generate code from natural language descriptions of what the code is intended to do. And it's interesting that in each case, the end user programmers who are participating in our studies, they really want to see the natural language prompt that generated a formula. They want to keep it, they want to use it as a bit of documentation, and in some cases they want to use that instead of the formula that was generated, right? It's a really natural tendency to want to take the prompt and say this is actually a stand-in for the formula that was actually generated as a result, and use that as a communicative resource. So I think today there's two big challenges that sort of stop us from using prompts in that way. The first is that because of the way that large language models work, we have no guarantee that the prompt actually describes what the code does, or vice versa, right? So that is something that is going to take some research effort to figure out how can we not only sort of improve the likelihood that there's a consistency, but also maybe even guarantee that there's a consistency. One approach that our team has explored is by taking the prompt language, sort of the prompt that the user, and that was published at Chi earlier this year, taking the prompt that the user has written, taking the generated code that the system produces, and rewriting the prompt that the user wrote very slightly, very minimally, as minimally as possible, so that it actually corresponds systematically to the code that was written, so that it becomes a useful thing. So that is one way in which one direction. The second thing is that the prompt, it has this weird dual characteristic. It's both an instruction to the system as well as an explanation of what the code does. And I think that is a tension that in some cases leads to, there are examples on a Chi paper from earlier this year, but it's a tension that sometimes leads to like a worst of both worlds scenario where you've got an instruction that's not very good at being an instruction, and it's not very good at being an explanation either. So I think if we can find a way to sort of either separate or unify the concerns of instruction and explanation in the prompting language, that would be really valuable. And it might be the case that something like that will evolve organically, much in the way that legal language or scientific language evolves. I don't really know. Those are the two kind of issues. Yeah. No more questions.
Great talk, thank you. I was curious if you have observed in your research already if the new wave of possibilities have also created maybe a false sense of trust with end-user programmers, wherein since the computer said it, it must be correct, and as such they start using things a lot more confidently, which may result in much worse errors, as people also trust larger chunks of code for more critical opportunities.
Yes, indeed. So over-reliance is an issue, and the way to solve that is to help people debug their code, identify bugs, and so those are the kinds of tools, like debugging tools for generated code that I think are really important to try and develop.
But then we are back at code, yeah.
That's right. That's right. So if you want to, when you say we're back at code, I think code is not disappearing entirely. The question is to what extent do we need the end user to read and engage with the code directly. And many of these debugging tools don't require necessarily the code. So the code might be represented in some other way. It might be represented as a sequence of examples, for instance, which don't require direct engagement with that formal system. Yeah. But it's really important. Yeah, I agree.
Good ideas. Thank you.
Thank you. I feel that end-user programming could be related to computational thinking skills in some sense. If end-user programmers change behavior, do some computational thinking skills become irrelevant?
Well, that's really interesting. I think so. CT has always certainly Jeanette Wing's sort of motivation for it has always been trying to distinguish computational thinking from programming, the act of engaging with code. So computational thinking, in terms of understanding modularity and sort of strategies for problem solving. And I think that is kind of what I was trying to get at with the awareness of the possible bullet point. I don't think computational thinking skills, particularly the skills that for an end-user programmer make them realize that there's an opportunity to automate something and improve their workflow, I think that is the really key thing that remains important with large language models or any kind of technology that allows them to improve their use of computers. It's that conception, that first step of figuring out that something can be done. But in terms of solving a problem concretely by using some sort of decomposition strategy, I don't know. I don't know how important that is for end user programmers to get their tasks done. Often, actually, people will write code in extremely sort of poor and inefficient and redundant ways that show a real lack of computational thinking background or skills. But it doesn't really matter for end user programmers as long as it works and gets them like further along their task than they were without doing it. Yeah.
Thanks for your talk. I'm Arjun Goa at Northeastern. So you brought up sort of formal natural language as is used in scientific communication and law, and suggest that there may be an analogy between sort of high quality prompting skills and that. I guess I worry that. So firstly, if that were the case, that would be fine. Lawyers write well, even if it's hard for some of us to understand it. I worry that isn't actually the case. For example, you can get away with some extremely vague, imprecise prompts. Like, for example, you can say, I don't know, write a function that removes the crap at the front of the URL, and it'll do the right thing. It'll strip off the HTTPS:// stuff. So any thoughts on that? Like, I worry that this may in fact lead to like a sort of stagnation where you can get away with sort of imprecise language for the problems that we already know how to solve, but to make that jump to new problems, additional technical skills are required.
Yeah. So I think if people can achieve what they need without having to also learn a very complicated prompting language, then people will gravitate towards it. It depends on what they get in return, right? So, for instance, in our experiments with restricted prompting languages, we've seen that this can give people a greater sense of control and predictability about when they can make the system do something and when they can't, right? That could be a valuable motivation for people to try and learn a more constrained language. It might also be a valuable motivation if it turns out that when you ask the large language model to explain a piece of code, the language that they get back looks very similar to the language that was used to generate that piece of code, right? So that is another motivation if you can ensure that round trip sort of property. So there are reasons why people might seek out developing these sort of prompt engineering techniques, but yeah, again, it's end users are kind of fickle, and they will do whatever is the sort of, to them, the easiest path to getting their job done. So it may or may not entail developing a prompting language. Yeah. Cool.
Let's thank our speaker one time.
Thank you.